Hello, welcome to section 9.1. We're going to talk about linear regression, which is a fancy way of saying we're going to find a pattern between a bunch of points that would be like in a straight line. And what we're going to do is find the equation of that trend line. So that's what linear regression is. There's a really big formula for it, but we're actually just going to go to our calculator and have the calculator spit out a couple numbers at us, like the slope and the y-intercept of a line. So we're going to roll right into this example, and then the one after this will be more of a story problem application of this. So in this first example, we're going to determine what a least squares regression line is for this set of points, and then we'll round our answers. So the slope and the y-intercept, when our calculator gives us those numbers, we'll round to 2 decimal spots. So what I'm going to first do is plot these 3 points just to get an idea of where this trend line is going to go. So I'm going to find where 3, 4 is. I'm going to go to where 7, 6 is, and -2, -4. So what a trend line is going to do basically is go right down the middle of our points. So if you would imagine, I'm going to draw a line going through this. That line that I have in green has a slope, and it also has a y-intercept. Notice that it doesn't have to touch our points. It's just going to go kind of down the middle and find a general pattern. But if I plot these 3 points, you can definitely see that it looks like there is sort of a linear pattern. As we're moving from left to right, you can see that my points are increasing. So what I'm going to do is go to the calculator. Oops, let's shut the ink off here. Okay. So what I'm going to do is go to Stat. We're going to go to Edit, and in for L1, what I'm going to do is enter in my 3x values. So I'm going to put in 3, 7, and -2. And then I'm going to enter in my y values that correspond to those, so 4, 6, and -4. So my points are in here. Again, it's 3, 4, 7, 6, -2, -4. So what we want to do then is go to Stat. We're going to go over to Calculate, and what we're going to calculate is this 4th option here, linear regression. And notice that it's in the form of ax plus b. That's that slope-intercept form where it's y equals mx plus b. So instead of using m for slope, they're using the letter a. So I'm going to hit enter for that. Now I have the TI-84 Plus, so it's going to give me this option. Some calculators might just kind of default to a screen that's going to flash linear regression. If that's the case, you're just going to hit enter. So L1 is what we use for our x's. L2 is what we used for our y's. I'm going to go down to where it says calculate, and it tells me y equals ax plus b, where a is 1.13 and my b value is -1.02. So I'm going to copy that down. Again, a is 1.13 and my b value of -1.02. So what I'm going to do, when it says determine the least squares regression line, what we're going to do is write this equation in this form of ax plus b. So my equation on my line is going to be y equals 1.13x minus 1.02. So your slope is the 1.13, and my y-intercept, so where the function crosses the y-axis, is the -1.02. So I want you to imagine what this would look like. And I'm going to switch color here, so my y-intercept would be -1.02. So the function is going to cross here somewhere, and it has a slope of just over 1. So a little bit more than 1 and over 1. A little bit more than 1 and over 1. So if I were to actually draw in this trend line, it's going to look something like this. And again, it's just a pattern. It's an approximation. We're going to be able to take a bunch of data points and figure out what a trend line is. That's what we're going to do in the next problem, is actually use that trend line to make some predictions for us. So in this next example, it says the following data represents the population in Milwaukee County from the year 2008 through 2013. So what I'm doing in this table is I'm indicating that 2008 is going to be my initial year that I'm going to call 0, and every year past that would represent, like for 2013, that would represent 5 years past 2008. So what we're going to do is identify first what our independent and dependent variables are. We're going to determine what the linear regression equation is. We'll interpret our slope and the y-intercept, and we'll make a prediction of the population in Milwaukee County in the year 2020. So as you can see off to the right, I have a little map of Milwaukee County. Those are a bunch of the cities that are in there. I think Greendale's included. You would have Bayview and a bunch of other cities that are also in here. A lot of those cities are what make up the population of the county for Milwaukee, but the city of Milwaukee itself has a population of approximately about 600,000. So that takes up a huge chunk of population. So what I'm going to do first is identify what's independent and what's dependent based on these x and y values. My independent variable is going to be time, and that's going to be measured in years. And what's going to depend on that time is going to be my population, and that's going to be measured in people. So there's my quantities and my units. The next thing we're going to do is go to the calculator and find what our linear regression equation is. So I'm going to go to Stat and Edit. In for L1, I'm going to start entering in my values of 0 through 5. Go over to L2 and enter in the populations. So 936,778, 939, 935, 947, 735, 949, 742, 951,315, and 952,054. So what I would encourage you to do first is take a look at this data. The population in 2008 was this first number, 936,778, and notice the population 5 years later is 952,000. So the population increased a bunch. What I want you to do is approximate right now how much it went up by every year. My guess is it looks like it was between maybe 250, 300 people every year that 2,000 to 3,000 more people every year. Notice it was 936,000. That's 939,000. So it's increasing by almost 3,000 people every year. Some years are more than others, and again, what the trend line is going to do is it's going to show us an approximation of how many more people the city is adding every year, and that's what's going to allow us to determine a prediction. So then I'm going to go to Stat, go over to Calculate, go down to the fourth option, and we're going to calculate our regression equation. So it's in the form y equals mx plus b. Our a value here, 3266. I'm going to round these two values to the nearest whole number. So I'm going to round this down to 3266 for my a value. Oops. I'll change color. I'll say a is going to be the 3266. And my b value, back up to this, I have 938,193. So these are my a and b values, but it's not the equation yet. So we need to write this in mx plus b form. So y equals, we're going to say 3266x, because the 3266 is my slope, plus 938,193. So the next part is very, very, very important. We're going to interpret what the slope and y-intercept mean in context of the problem. So first of all, what does the 3266 mean? And then what does this 938,000 number represent? So first thing is the slope. And that's why, like a couple minutes ago, I suggested going through and approximating what it looks like our population is increasing every year. And that's because your slope is going to be that rate that's going to compare your dependent variable to your independent variable. So what I mean by that is it's going to compare your population to the number of years. So, and I'll write this right below here. So I'm going to write that the slope 3266 represents the approximate increase in population per year. So again, what that means is every year there's approximately 3,200 people being added to the city, and that's why, as you can see, from 2008 to 2013, it seems like it's a pretty big increase because we're going from 936,000 to 952,000. So we're gaining a lot more people in the city. What the other thing is I want to do is identify what the y-intercept means in this case. So the y-intercept is 938,193, and what that's going to do is represent the approximate population in 2008. So the y-intercept is the value that corresponds to when x is 0. So imagine if I were to substitute 0 right here for x into my equation, I would end up with this 938,000. So what that means is, even though my actual population is 936,000, when we use this equation, we're making an assumption that our y-intercept of our trend line is 938,000. So it's an approximation. We know that the actual population was the 936, but again, the slope and the y-intercept are just approximate values for what the number is increasing by every year and what the approximate starting population was. So I'm going to use this equation then to predict the population in the year 2020, and I'll just show you how to do this by hand then. The year 2020 is how many years past 2008. So 2020 minus 2008 means that this is 12 years later. So what that means we're going to do is use a value of 12 to substitute in for x. So y equals 3266 times 12 plus 938,193. So I'm going to go ahead and throw that number into my calculator. So I have 3266, oops, let me go back and delete this, so click that, times 12 plus the 938,193. And I end up with an answer of 977,385. 385. And that is people. So take a look at our data here. So over a span of 5 years, we're going from 936,000 to 952. So we're going to keep going an additional 7 more years past that, and that's why our population approximately would be 977,000. So it seems like it's a reasonable approximation. It seems like we can follow that our population is growing in this maybe a linear trend, and that's why we're able to use a prediction model with linear regression. So again, just to quickly recap this, it seems like it's a short video. We just really did linear squares regression. It's the same thing, or least squares regression, same thing as linear regression, where what you're doing is entering in your x values for L1, your y values for L2, and then for this example, we used our time for our x values for independent, we used our population for the y values for dependent, and we were able to use our regression equation to make predictions.